This is the screencast for section 2.2, example 3. In examples 1 and 2, we learned about power functions. Now we're going to learn about monomial functions. They look exactly the same, except, so I guess that wouldn't be exactly the same. The k value is a constant. It can be anything. The exponent has to be a positive integer. So in other words, positive integer would be, well, let's see, 1, 2, 3, 4, ... So no more fractions, no more negatives. Monomial functions are only positive integers. Now they are also power functions, they're just a more specific power function. So let's look at example 3. Describe how to obtain the graph of the given function from the graph of g of x equals x to the n with the same power n. Sketch the graph by hand and support your answer with the grapher. Okay, so in this part A here, f of x equals 2x cubed, which means g of x would have been x to the n, so just x cubed. Which means the transformation that took place here was a vertical stretch by 2. So I'm going to sketch that by hand. It's going to look like a nice, long, tall, skinny, basic function, a y equals x cubed basic function, just vertically stretched by 2. Now I know that your graph isn't a perfect sketch because nobody's perfect. But that's why you identified what kind of transformation took place and you drew yours a little bit skinnier. It is just a sketch, it doesn't need to be perfect. So now let's graph. I put in y1 my x cubed graph, in y2 my 2x cubed graph to make sure that my graph should have looked a little bit tall and skinnier. There's regular x cubed, and then there's my 2x cubed. So I was correct. Now, part B. F of x equals negative 2x cubed x to the 4th. Okay, x to the 4th is not one of my basic functions, but I'm familiar with it enough to know that it looks kind of like a parabola. So the g of x function is going to be plain old x to the 4th, which means f of x is going to have a vertical shrink by 2/3 and a vertical flip over the x-axis. Okay, so instead of the graph looking like this, it's going to be shrunk, so it's going to be a little bit, it's going to look smushed down towards the x-axis and flipped. So it's gonna, I think that's the best way to represent my sketch. Now let's see, in my y equals, I put x to the 4th in y3 and then negative 2/3 x to the 4th in y4 to see how those graph. There's regular y equals x to the 4th, and there's my little bit more smushed towards the x-axis and flipped g of x. Now if I want to see that a little closer, I can hit zoom 4. That's a little bit better. So my sketch was accurate. The now try problem for example 3 was number 31. Describe how to obtain the graph of the given monomial function from the graph g of x equals x to the n. So in this case, g of x is going to be x to the 4th, just like part B of example 3, with the same power n. State whether f is even or odd. Oh, they're throwing in a curveball. State whether f is even or odd. Okay, so I'm going to off to the side plug in negative x. Before I'm even graphing, I'm going to state whether it's even or odd. I can do this without my calculator. If I raise a negative to the 4th power, it goes back to positive. So I end up with the same thing I started with whether I plug in regular x or negative x. That means the symmetry here is going to be even. Now sketch the graph by hand and support your answer with the grapher. So my sketch by hand, let's see, well it doesn't say state the transformations made, But in order to sketch, I need to know what those transformations are. So I'm going to call this a vertical shrink by 2/3. There's no flip like example 3 part B, so it's just going to be a little bit smushed towards the x-axis. So let's graph with the calculator just to make sure. I'm going to leave x to the 4th in y3. Then in y5 I have my 2/3 x to the 4th. Let's see what happens. There's the original, and there's the little bit more smushed one. Not much, it was only a smush of 2/3. Shrink is the official word, I guess, not a smush.